Good afternoon, everyone. This is Stuart Stow. I'm the Director for Homeland Defense and Security Information Analysis Center. Welcome to this week's Biometrics webinar. We have with us Eric Bowman, who is the Technical Fellow at NGIS and the Chief Engineer for the Department of Defense ABIS program. At this point, I'll go ahead and turn it over to Eric so he can begin with his presentation.
Thanks, Stuart. So again, this is Eric Bowman. I am with Northrop Grumman Information Systems. I'm a technical fellow and currently the chief engineer on the Department of Defense Automated Biometric Identification System. Before I get into my briefing, I did want to give a little bit of background on myself before we jumped into the agenda and subsequent slides. I've now been in the industry about 20 years, either working as an analyst about the industry, or working for some of the companies that supply the searching and matching algorithms that we'll get into a little bit later, and now working for a systems integrator who brings it all together in terms of supporting the missions of our various DoD or DHS customer sets. As I started in the industry, I don't have necessarily an engineering background. I have an MBA. So I'm all about the business of technology rather than the technology itself, although I do like the technology. So I'm about advancing the technology from a practical business point of view. So when I start talking about the research topics, they're from a business and technology point of view. I started off looking at the industry from the various companies in the industry when it was a very nascent industry back in the late 90s. And you kind of move through the industry, whether working as an industry analyst writing about the companies or working for the company as a solution engineer. So I've spent time at Identix, which is now MorphoTrust, and I went through the iterations of those companies, and now work as a chief engineer on the DoD ABIS program. So I've grown up in the industry. I've been fortunate enough to be able to stay in the industry. And with that background, I'll get into the agenda. I've got 3 topics that I want to cover, and the last one is the one that the discussion itself is about. But before I get to what the discussion itself is about, I wanted to walk through what biometrics were at a very high level and how the industry defines itself and how it presents itself to the supply chain. Whether the supply chain is direct to the customer or through systems integrators like Northrop Grumman or through other distribution channels. Next, I want to talk a little bit about the biometric transaction processing, kind of at a 100,000 level view from capture all the way to process and sending response back. And so with that as a context, we'll then get into the industry trends and research problems that we see in the industry, that I see here at Northrop Grumman. And in addition to my duties as chief engineer, I also oversee a lot of the biometric research and development at Northrop Grumman itself, participates and invests in, and I'll be giving you some examples towards the end of the briefing itself. So with that as an intro, we'll jump right into the definition of biometrics. So what are biometrics? So this is a definition that the industry has been using for ever since I've been in the industry, and I really like it. It's all-inclusive, and it separates manual from automated methods. So the definition, as it states here, is the automated methods of identifying or verifying an individual based on a physiological or behavioral characteristic. And so the letters highlighted in blue I wanted to parse through because those are very important to the overall definition. And the modalities, biometric modalities, you see iris, face, latent, fingerprint, voice, and hand geometry are but a smattering of the actual technologies that are out there right now, either commercially available or being looked at in academia. So there's constant research going on outside of the modalities that you see here, iris, face, and fingerprint. But they all the modalities and all the explanations of biometrics fall within this category, within this definition of automated methods of identifying or verifying an individual based on a physiological or behavioral characteristic. So with that as a definition, we'll start parsing through what each of the operative words mean. The first, which is automated methods, and simply what this means is that you're going to have a machine learning algorithm try to find the salient points of a fingerprint, which we call minutia points, or finding unique points of a face, and putting machine learning algorithms to automatically identify and mimic what we do as humans on an everyday basis. We all recognize our friends' faces and so sometimes our foes' faces, but that process in our brain that we're going through is an automated recognition. So the machine learning algorithms that the vendors and the cost providers create try to mimic what we as humans do, and whether that's faces, we recognize, friends from foes and siblings as well, down to the way that fingerprint examiners classify fingerprints as having whorls or loops or arches and patterns. So there are patterns to fingerprints that the fingerprint examiners would classify a fingerprint as, and they would literally say, put it in a bin or a box to say, these are all whorls, these are all loops, and these are all arches. And when they got a new fingerprint in, they would classify it, the probe image or the image that was in question. Oh, this is an arch, so I need to search I need to look in the arch bin. And so what the automated methods have done is they've removed the human and automated the way that you search for the salient points of a fingerprint or a face or an iris. So that's kind of what we mean by automated methods. Identifying or verifying, that essentially comes down to identification is answering the question, have I seen you before, or do I know who you are? And that's the question that's put to the system every time a face, a finger, an iris, or a latent image is presented to the system is, do I know who you are, or have I seen you before? And that's what we call a one-to-many search type, and that's essentially like trying to find a needle within a haystack. And that's what these automated methods and automated search algorithms do in terms of trying to separate the good candidates from the bad candidates and effectively giving an answer of an identification or a non-identification or an inconclusive. And then an inconclusive would be routed to an actual human examiner. But the identification component within the definition of biometrics is one of the hardest to answer. Just the question again is, have I seen you before, or do I know who you are? On the flip side, verification is relative to identification is easy, and the question you're answering there is, are you who you claim to be? And what I mean by that is, every day we have to sign into a computer, and we present ourselves as our username and our password. In this case, what we'd want to do for biometrics is you have a fingerprint reader attached to your computer, and you can log into your desktop or log into a website, or like they have in the Apple iPhone, log into and pay for goods and services. And essentially a one-to-one search type is if you're making a claim to your identity, whether it's through a PID card or a common access card, and it's verifying what the claim is to what's being presented by the sensor. And so essentially you're pulling up a record, and that record has in the case of a fingerprint template that it has ready to match, and you present your finger to the sensor, and then it matches those two. So there's no lookup in a large database in terms of comparing. It's just serving what you registered as to what you're claiming to be, and it results in a match score. And typically, those applications are for physical access control, whether it's getting into a building, getting onto a computer for logical access control, or now even in time and attendance. And one of, I think, the better uses, it's not a security use necessarily. One of the first uses of biometrics that I came across was the University of Georgia was using biometrics, specifically hand geometry, to authenticate their students' meal plan. So you go get your meal, and you would check out, and instead of using cash, you're going to put your hand down on this machine that would essentially look at the three-dimensional shape of your hand, and if it verified, said, yep, you are who you claim to be, you can get your meal. Now, the problem they were trying to solve in the University of Georgia were people passing around their meal cards to people who didn't have meal cards, and the parents weren't liking having to replenish the meal cards as often as they had planned on it. So there was a fraud effort there. So typically you would think of biometrics in high security type of areas. And while that is true, there are non-security applications for biometrics, and specifically one-to-one verification. Time and attendance is another good application of it, where they don't like the buddy punching, where I clock out for a friend of mine or clock back in for a friend of mine who's actually out at lunch. So there was payroll fraud that they were trying to reduce. So biometrics is a way to proof positive identify you are who you claim to be. And some of the one-to-many or identification applications are one that I work on here every day, the Department of Defense Automated Biometric Identification System, where we're trying to identify bad people trying to do our coalition forces harm. So that's, again, a one-to-many type search. So that's identification versus verification, or one-to-many versus one-to-one searching. So this is where it gets interesting in terms of breaking it down on what biometric types there are. We break them into physiological or behavioral. And the physiological characteristics that are biometric identifiable are the traditional ones you would know about: finger, palm, face, iris, hand geometry. Those are well-established, commercially available products that have been around for many years, and what you would typically see in a national identification or a state fingerprint system, so that because they've been proven, they've been around quite a long time. The behavioral traits tend to change frequently, as I say here, because I know I don't sign my name the same way every time. I may not say a specific phrase every time the same way, and I may not walk the same way, and I may not type type a passphrase in the same manner. But these types of traits or biometrics are on the rise, as we'll see when I start talking about trends within the industry. And the point about this is that you wouldn't necessarily use a voice to do a one-to-many search by itself. You would use that in combination with finger and palm or face or iris. So the more what we call sensors that you have about a person, the easier it is to identify them. Because what we're seeing quite frequently in practice is you're going to get bits and pieces of a person as they're collected over the years, and they may not present themselves as an encounter the same way. So the more biometrics you have on a single person, or what we call the multiple modes on a person, the easier it is to identify them. So that's how we kind of split up the world between physiological and behavioral. I mean, each of them have different characteristics. Again, the physiological traits tend to be more trustworthy, have been around a lot longer, and the behavioral ones are up and coming. So now that we kind of understand what biometrics are from a definition point of view, let's talk about how they're used in kind of a larger scale processing, from capture to match. And then we'll get into the industry trends and research topics. So this picture, we're going to look at it starting with the soldier and go clockwise to explain. This is an operational view of the system I work on, the Department of Defense Automated Biometric Identification System. And I want to talk about it in terms of its processing and the actors that are involved within the whole process of matching. So we start out at the originator. We call the originator the soldier out there. Typical use case for our system is combatant commands will be on target, and what they're going to do is they'll have handheld biometric enrollment devices with them, and they're going to enroll, for example, all the military-aged males in the village that they go into, and they're going to take the fingerprints, the faces, and the irises of those individuals and send it back to our system to see if they're a friend or a foe. And those submissions are come into us either via email, secure file transfer protocol, or if there's a bunch of fingerprint cards that include faces and potentially iris images, we can take in media. So all that information is sent to our system via satellite, via courier or what have you, sent into our system, and then our system then does the matching. And to give you an order of magnitude, we receive between 8 and 10,000 submissions every 24 hours, that include a mix of finger, face, iris, palm, and latent images. So our systems are very busy. It's a 24/7 system. When the submission comes in, it has one of 3 what we call disposition or decisions that are outcome. One is an automated identification, meaning the person you have in front of you is a known or suspected terrorist or a bad person. An inconclusive, which means the algorithm said, I think I know who it is, but I'm not going to be definitive. And then the final disposition is, you're not in our database, then we're going to enroll you. Or we have some cases where we may not enroll you due to specific business rules. But in the case where we have an inconclusive, or what we would call a yellow transaction, where the algorithm says, I don't really know, I don't really think I know who you are, but these are the candidates that match close enough. Those have to be routed to a human. So if we go up to 12 o'clock on the diagram here, you'll see biometric examiners, and those examiners are looking at fingerprints, faces, and latent 10 prints, or latent prints that come in and that have to be searched. So you have a human looking at, for example, a 10 print a fingerprint 10 print, or right index and a left index, or right thumb and left thumb that don't match automatically. They're going to have to look at it on a screen using tools and analysis tools to determine whether or not that's a match relative to the candidates that get sent back. If I talk a little bit about the candidates, if you imagine our repository has 12 million records. Each record could have up to 20 fingers. 20 fingers. You'll have rolled plus slap images. You'll have 2 eyes, 2 irises, and then up to maybe 5 faces. But we just want the full frontal face. So we have a lot of images within our database that have to get searched. So those images, for comparison, are sent back to these examiners. The 2 other actors that are attached to the system are our system administrators who keep the system running, adjudicate problems relative to the system, and then there's the watch desk, which is the first line of defense, or our tier 1 support, where if a combatant command or a submitter to our system has a particular problem, they'll call there, and the watch desk or help desk will be able to help them through the issue. On the kind of right side of the screen of the operational view, we have other submitters to our system outside of the Department of Defense. So DHS is a big submitter to our system. NGIC, the National Ground Intelligence Center, is an observer of our system. So they take the biometric matches that we make on the submissions that come in from the field, and they add intelligence to that match to give a better intelligence view of that particular record for a particular policymaker, for a decision maker that needs to make a decision about whomever NGIC may be looking at. So we're giving them proof positive identification of people that they're looking at, that they have been found, and they are in our system, and then the NGIC analysts will add intelligence to that particular case. So that's kind of a transactional operational view of how our system works. The submissions come in, they're adjudicated as either an ident or a non-ident or an inconclusive, and those inconclusives go out to an examiner. The examiner, human, has to make a decision, and then once that decision is rendered, it's sent back to the original submitter or observers. We have people who observe matches from our system that aren't necessarily the direct submitter. So this is just this slide kind of represents the potential customer functions that I talked a little bit about or alluded to in the operational views, is going a little bit deeper. So Any biometric system transaction system that you come across will have these 5 high-level characteristics. Is how we have built and deliver our system to the Department of Defense. The first box you see all the way to the left is called ingest, and it goes from left to right: ingest, pre-process, search, post-process, and response. And on the ingest, that is taking in the submissions from either the handhelds or fixed workstations, biometric collection workstations that sit out there, or the handheld biometric collection devices that are collecting the various biometrics. So ingest to us, as we receive that input, we authenticate the submitter to make sure that they're the right submitter. They can commit to our system, and we do some other work on that submission. Pre-processing is where we, in effect, open up the envelope of the biometric and non-biometric data that's sent to us from the field and parse that and get that ready for the various next stages. The next stage is search, so we have to take the biometric images out of the electronic envelope, in effect, and then present them in the right manner to the search engine. And the search engine for us is a commercial provider, and that does the finger, face, palm, iris, and latent matching. The post-processing is where we gather all the results up from the searches for the various modalities, put those together, make decisions about who the right candidate is. It's also where we do something called fusion, and I'll get into that a little bit later in the briefing, where we fuse scores from the results of the search engine to make a potential candidate that was below an automatic identification move up to an automatic identification. And then, of course, our last box is response, packaging that response up into an email or some other format that goes back to the submitter itself to know the answer to the question, do I know who you are? A little bit more about this diagram. So ingest, pre-process, post-processing, and response are all built by Northrop Grumman. And then the middlemost box, search, is what we implement a commercial off-the-shelf provider search engine. And we can implement any of the various search engines that are out there, because there's a lot of different companies within the industry that we could integrate. So we're not locked into one specific vendor. So if I move on to the next slide. So now that we have an idea about how the processing works from an operational view, as well as from a more detailed essential customer functions point of view, I thought it interesting to kind of do the top N number of large-scale biometric programs that are out there kind of in the world operating on a daily basis. We have, as I say here, about 12 million records, about 15,000 transactions per day. We have peaked at about 30 to 40,000 transactions in a given day, 24-hour period, where we're receiving fingers, faces, irises, palms, and latent images. The UK IDENT1, the IDENT1 system in the UK is very similar to the FBI IAPIS system, where it's about 15 million records, not in terms of size, but in terms of mission. 47,000 transactions a day. The largest one on here is kind of a tie between the DHS IDENT system and the the UID system in India, where you got hundreds of millions of records and you have hundreds of thousands of transactions in a particular 24-hour period. Big system, and lots of transactions in a specific day. Department of State is primarily face recognition, but these are some of the larger systems that are out there active in the industry. So I just wanted to kind of give you an idea of what some of those systems were. So now let's get into what the topic was about. I'm sorry I spent 15 to 20 minutes talking about the industry definitions, but I thought it was a good context to get into the industry trends and research problems. And what I'm doing here is splitting between business and technology trends. So the business trends that will likely drive the technology, and then technology will have its own trends and its research. But I think it's the business that drives the technology. That's why I thought it interesting to talk about and talk through some of these business trends that and technology trends that I've observed. Mergers and acquisitions have been happening for quite a bit, within our industry, and the value of them have become larger, which is indicative of a market actually becoming a market itself, as opposed to a bunch of small players, cottage industry led by universities. Now we have large players, large acquisitions, serious research and development funds within the companies that are really pushing the industry beyond where it was 10 to 15 years ago. And the customers that I mentioned and the people using it on the previous slide are really pushing and changing the industry, because the larger the biometric system gets, the more difficult a problem it is to identify the right person. Another interesting trend I've seen here is the consolidation of state automated fingerprint identification systems, or the booking stations, and what the local police stations will be using to search. NEC has, as an example here, has consolidated a lot of its West Coast customers into a single data center. So you can see that as an infrastructure and software biometrics as a service for state agencies, because they're consolidating into a single data center. So you could potentially call that a bit of a cloud, and cloud has always been obviously an interesting topic when it comes to biometrics. The COTS providers themselves are growing up. The mergers and acquisitions, the money that the various companies procuring them are putting into are making them medium-sized systems integrators. And so they'll be sometimes competing potentially against the large systems integrators, because they're learning about all the things that typical large systems integrators provide on programs. So I see that as a trend that's continuing. The medium-scale biometrics programs abroad, Australia has a couple that are going on right now, and New Zealand, as obviously as well as in the UK. These are going to proliferate more and more as biometrics become more of a mainstay within culture. And I think more and more people are getting used to using biometrics. I mean, Apple put a lot of thought into when they wanted to roll out biometrics, and now it's becoming very much part of the mainstream, which is interesting. The cost biometrics research and development turning to cloud is an interesting one too. I see a lot of the COTS providers, not necessarily the large systems integrators, getting into and exploring cloud. And I'll talk about cloud from a research and development standpoint later on in the talk. The financial industry is one that's kind of overlooked quite a bit. They use voice verification quite a bit, and they're continuing to push that usage. They often use voice verification to verify transactions, as opposed to using PIN numbers that can easily be hacked. I've talked a lot about the mobile phone providers, whether it's Samsung, HTC, Apple, all getting into biometrics. Samsung, I think, is going to have, if they haven't already, a fingerprint reader embedded into their next generation phones. They already use face recognition. Of course, the Apple iPhone has been doing fingerprint recognition for the past year, if not longer. And then hopefully national identity schemes will continue to be popular. The India project to enroll all of its citizens for social and civil benefits is a great example of how you can get a nation with 1 billion people enrolled and using biometrics and advanced identity schemes and advanced card technology to provide services. Hopefully that continues. I've seen one in the past, whether it was Spain or other countries, where they've tried to do a national identity scheme and it failed because of privacy or social concerns, and they're real concerns. But if you work at the privacy concerns early on, hopefully it can ease the implementation and sustainment of a national identity scheme. From the technology side and trends, DNA, where it used to be kind of something that was we talked about in labs only, is very real. It's very here. The FBI is committing to their their rapid DNA prototyping. They want to start using it more and more. They have a large database that they want to start doing automated DNA matching, and there's providers out there that can do a DNA from sample to match within 90 minutes. Additionally, there's research coming out of West Virginia University on touch DNA. So if you have a fingerprint, you could collect DNA from that particular fingerprint. Multimodal biometric fusion becomes more important for large-scale systems. As I was saying before, the larger your system gets, the more sensors you're going to need to identify that person or those people. And the fusion that happens across those modalities, and there's many different types of fusion schemes, will enable you to put the right candidate above that matching threshold line. And what that means to a customer is that you won't have to send out as many inconclusive matches to an examiner, and those examiners are very expensive. So you want to have the examiner working on only cases that are really high profile or needing to be solved. You don't want them working on things that a machine could otherwise do. So this is where multimodal fusion research is going to become very interesting. Voice biometrics, as I kind of said before, is on the rise, and this is not necessarily one-to-one speaker passphrase. This is more about speaker identification, where you may have a recording of an individual, and then you may have an interview with that individual, and you're matching the voice option, not necessarily looking for specific words, but it's the way they say those words that you're looking at. There's companies out of Spain that are having very good success with the Spanish police departments in helping to solve and find criminals. The identification of individual non-ideal environments. This is a research topic that is becoming very, very, very important as we want to push the borders that we're trying to protect out further. So the research problem here is, can you do, for example, face recognition at night when it's raining at long distances of up to 200 or 300 yards? Because it would be very good to be able to push a security perimeter out beyond a blast zone, for example. And so there's a lot of research in the university level, as well as we're doing, Northrop Grumman's doing research in trying to identify individuals in non-ideal environments, whether it's using face, gait, the way you walk, or voice recognition on video surveillance. And so you're trying to get individuals at various pose angles and in various environments, whether they're sunny, whether they're dark, whether it's dusk, or your different angles. That's not an easy problem to solve. And the ongoing debate in terms of cloud versus high-performance computing, this is an interesting one, and I think I understand the need for cloud-based solutions in terms of computing power, because in effect, biometrics are, for the most part, loaded in memory, and the more memory you have and more CPU power you can throw at the automated matching problem, the easier it is going to be to find that needle in the haystack. The concern that we, kind of Northrop Grumman, and I would imagine the other aerospace and defense companies would have, is how do you secure that data that is in that cloud? And that becomes very important when you're talking about biometrics and aggregation of that biometrics if they're ever compromised, because you can't replace someone's finger, you can't replace someone's face. If they're aggregated, stolen, or compromised, that becomes an issue. So we're working on security approaches to secure things within a cloud. I'm not saying we're against cloud, I'm just saying we're approaching it from a security point of view, because we know the customers that we serve have very important and sometimes classified data. On the flip side of that, high-performance computing platforms are very specific to the application, more scientific application, but they're stripped-down versions of an operating system that will work in a very effective manner. And maybe what we're going to see is a combination of high-performance computing in the cloud or in a data center. But those are some of the business and technology trends driving the research trends that I'll talk about in a couple of minutes. So the research questions that we're always getting from our customers, or that are talked about amongst the research communities, The first one's from our customers: how do we drive down the total cost of ownership of a biometric system? And as I've alluded to before, a big cost of the system is that the examiners, so they're people that you've got to pay, have on staff to look at those inconclusive matches. And really, I'm not necessarily talking about eliminating jobs as much as I'm talking about having them work on very difficult problems that of a system right away, as opposed to having a backlog of issues. The other question of the three is, how do we increase accuracy of our system? Again, I've alluded to some approaches and active research areas like multimodal fusion is a way to increase the accuracy of the system and keep the inconclusives down and only send to the examiner what they should be looking at, as opposed to sending them garbage data. The last question is, how do disparate systems share data to create actionable intelligence? So of the systems, like 7 systems I talked about before, they do share data. It's not as automated as it needs to be, and it's not necessarily as interoperable as it needs to be. So how we share data, the data formats need to be reconciled. I'm not saying that they're not now, but it's not as easy as it needs to be, so that these systems that, whether it's DHS, DOD, Department of State, and DHS, all need to be sharing data in an automated fashion so that the searches are faster, that they're exchanging data, so in the hopes of catching the person that we're trying to catch in a fast manner. So those are the big kind of research questions. How does that kind of break down in terms of what projects are happening out there? So there's 2 sides to the research area that we're always interested in, and we're actively funding within academia, and then there's one that we Northrop Grumman fund ourselves. So what I thought I'd do is kind of talk about the Center for Identification Technology Research, and that's the foremost research center that brings together industry, academia, and the end user communities. And the point of CITER is to fund PhD students in biometrics to fund research projects that are at the technology readiness level 2 or 3, and then we can take those, the members of CITER can take those and make them commercially viable. And some of the topics that are active right now in CITER and being researched, funded and researched, are these 10 that I kind of picked here of the 20 that were funded last year. Liveness detection for fingerprints, that's becoming an interesting one, where if you can detect that fingerprint is still attached to a body and not either a fake fingerprint or otherwise, that helps with telling the authentication mechanism that you actually have a human being there and not a fraudster. Credibility and deception detection is very interesting, and there's lots of research in how you answer questions, the inflection in your voice, how your face pose may change, and that's very useful when you're interviewing either detainees or people at secondary inspection to see if they're trying to create a story or lie about you. Cancelable biometrics has been a research topic for the past 4 or 5 years, and that's really targeted towards commercial use, so that if your biometric is ever compromised off your iPhone or off of a database somehow, you can cancel that so that you won't have, so that person who stole it won't be able to use it again. Heterogeneous facial recognition, so this is an interesting one, very applicable to us in the DoD or anyone who's trying to get and find people from various input devices. So this is really, we have a lot of still photographs that have been taken at, as I was saying in that operational view, on target. So they take a picture of the person, but oftentimes we can get in video from a various source, and we'll need to take that video and start to clip out the faces within that video and try to match those against what's in our database. So you're trying to match still photographs against video frames that are coming in. So there's a lot of research in figuring figuring that out, and I'll go into what that is in a little bit too, some of the research we're doing. Cross-device, cross-distance matching the face on mobile devices. As mobile devices proliferate, which they are, we've seen that getting those into the hands of people that need to catch the bad people. There are different cameras that are in these devices that use different resolution. So that research project is interesting to us because it's using a cross spectrum of various mobile devices. And the research results that come out of that project are very applicable to one of the handhelds that Northrop Grumman produces. Active and long-term user authentication, this is an interesting one from the standpoint of what you would do on a daily basis when you log into your computer or you interact with your computer at work or at home, where it needs to know if you're still out there and working on your computer. So it's going to challenge you to verify that you're still out there in front of the computer, whether it's going to use face, whether it's going to use fingerprint, or some other mechanism. Again, writer identification and verification, so that's back on the rise again in terms of how you sign things. So it's looking at the way the pressure movement on various angles and things of that nature. So there's research going on around that. This is another interesting one, fingerprint identification, a longitudinal study. That's looking at how a fingerprint ages over time. So a lot of the databases that are out there now that have repeat offenders have been committing crimes since they were a teenager, and now they're maybe in their 50s or 60s, and we have anecdotal evidence that the fingerprint does tend to change over time, but this specific study is trying to put quantitative analysis to prove that. Touch DNA, that's a very interesting one, and very applicable to the Department of Defense, because the stringency and proof like you'd have to have in the Department of Justice in terms of proving it in the court of law don't necessarily hold up the same in the Department of Defense, so this is very applicable, where you're going to pick up DNA from a latent fingerprint. Again, West Virginia University is working through that. Using biometric and biographic information. That's very useful if you have the biographic information that's believable. Unfortunately, in the Department of Defense, we don't have a lot of that. So other systems, whether they're more cooperative, that people want to give you their right first name, the right last name, the right date of birth, you can use the biographic information to help penetrate or search that data space a lot faster, so your results come back faster and more accurate. So those are what's going on kind of in academia. We then take a lot of the research that's happening inside our academia and apply them to our missions for our customers in a larger scale sense. So we take what they're doing at a technology readiness level and make it more level 6 to level 8, so more commercialized. So if you ask Northrop Grumman what its biometric research and development priorities are, these are those, a high-level overview of what those are. So we're, again, very focused on what's the mission for the specific customer, whether it's catching people coming across border at night. Okay, that's going to involve potentially cameras, thermal cameras, integrating face recognition, integrating clustering algorithms. So it's a bunch of machine learning algorithms and sensors that we'd have to integrate into an offering. Very large-scale processing, so we think about transaction processing in the tens of thousands or hundreds of thousands, and those with very large payloads of up to 5 megabytes when you consider that finger, face, iris, palms are all weighty type payloads. They're not like a financial transaction, it's very small. So we have to figure out how to deal with that from a transaction management point of view, prioritize those transactions, et cetera. So that's very important. And we're doing lots of research around that. Multimodal biometric collection and matching. So I'll show you a device that Northrop Grumman is producing that is doing collection of finger, face, iris, as well as matching on the device. And again, standoff biometric capture and matching, meaning at first we're starting with face recognition, but we also want to move into iris at a distance or iris on the move. And then, of course, the big one, increasing accuracy as data sets get larger. As the data sets grow, and they are, if you consider we have 12 million records, The Department of State has 275 million. There's over 200 million records within, I think, the DHS IDET system. If you have a single top search algorithm looking at it, as the system gets larger, the more alike the images look to the algorithm. And so that's where this multimodal fusion or unimodal fusion comes in, where you're introducing two vendors to look at the same fingerprint and reduce that candidate space even more so to get that right identification. And then, of course, we're looking into the cloud technologies or infrastructure as a service, software as a service, but with our focus on securing that data, securing access to that system, et cetera. So those are the research topics that where we borrow either from what academia has done or what we're very good at within a large systems integrator. So let's talk about a little bit about the projects that we kind of have going on here. So this picture here represents a lot of the research projects that we have going on right now. If you were to look at it from clockwise, the standoff biometrics, which I have a specific slide to talk about, going clockwise, you have what we call our biometric identification system that adds in biometric identification intelligence system that adds intelligence to the biometric matches. That's the system I discussed before that is being used by the National Ground Intelligence Center. You have BioVector, which we're calling a product name that we're kind of calling our finger, face, iris, ingest to response matching system. The notion of brokering communications between large-scale systems is what we call BioBroker, and then BioSled is our mobile handle, which I'll talk about a bit about each of these, because they're active research areas for us that we would like to turn out into solutions. And in some cases, we have those solutions already in customer spaces now. Counter biometrics is very similar to the research project Insider for cancelable biometrics, but here is how do you actually protect that template that's on board that particular mobile device from a hacker. So let's talk a little bit about the various devices or research projects that we've made over the years. So the BioSled, as you see here, the handheld device that's going to collect finger, face, and iris on a handheld device. In this case, we're implementing the Samsung Galaxy S5 as that device that will collect and match the fingerprints collected in the field itself. This was born out of research and development within Northrop Grumman over many years, and our focus was to get the best of breed for finger and face and iris sensors, and then integrate the best of breed matching algorithms and put it together in a easy-to-use interface. So that's what we're offering for the mobile handheld collection market. And as you can see here, it's something you can hold in your hand. You have the fingerprint sensor that's an inch by inch or a little larger fingerprint sensor that can collect all 10 fingers, 2 at a time, and then the thumbs, and then enroll and submit those to a system like an ABIS system. Outside of mobile, the standoff biometrics are trying to find a face in a crowd is exactly what we're showing here, where you have multiple Internet protocol-based cameras taking in multiple frames at a time and serving those up to be matched by a system. And then what I'm showing here in this case is you've got a picture on the top, a picture on the bottom, a picture that has multiple people in the frames, and then matching those all together. So what we've done is implemented or integrated a commercial off-the-shelf facial recognition provider, and then we ourselves have developed clustering algorithms and to cluster like faces together to increase the match probability. Multimodal fusion, this is always an interesting topic, and it's a way to make the system more accurate. I referenced the book here by Dr. Arun Ross, et cetera, because it's a great book to go look at if you want to go understand what multimodal biometric systems look like and how they can benefit from fusion approaches. It's an active research area for us. We've applied for some patents on novel approaches to using biometrics to make the system more accurate. And this slide relative to fusion strategies, there's many. Our sweet spot from a systems integrator point of view is at the score level. And if you remember back to when I was telling you about what the search algorithms themselves put out in terms of a response, they give us a score, it's a confidence interval, and then we take that confidence interval for the finger, the face, and the iris, and then we can apply weights to them, we can rank them, but it's a perfect area for us as a systems integrator because we can always take in scores from multiple cost providers. So that's why I have that highlighted in red. There's other types of strategies that you can implement, but you have to have intimate knowledge of the devices, for example, and we don't have that because we're not a device manufacturer. So that's why we kind of put our attention and our research focus into the score level fusion approaches. Cloud biometric processing, I believe this is my last slide. As I said before, biometric processing is all about CPU utilization and lots of memory. And that's how the cost providers do their matching. They do it using those two components of the computer. And the more you have, the better it is, and the faster you can get that response back to the submitter itself. The big question for us is how do you secure that data from being aggregated and being compromised? And we're looking into ways to actually secure the data in flight if you were to send it to a cloud provider, as well as secure the data at rest. So that's very interesting to us. And with that, I'll close the briefing. I thank you for your attention, and we'll take any questions.
Eric, thank you so much for your insightful briefing. We appreciate the opportunity that he's given us on understanding more about the biometrics program within the Department of Defense and specifically with ABIS. If you do have any questions, please feel free to reach out. And again, we thank you for your attendance this week. Have a great week.